So for some of you seeing this later, you will need a note card, or if you're in class, I might have some of these done for you. We'll see. But we're going to make ourselves a little cheat sheet here when we get a little further in. But before we get there, little warm up from some things we've been doing the past couple of days. Because we've mentioned words like amplitude, midline, and period, and I want to go back over some of those on how we would locate them. Amplitude, okay? Amplitude is how high and how low do things go. So when we were doing our amplitude before, we were basically taking our maximum value minus our minimum value and dividing it by 2. So, first job, not shocking, we need to know what the max and min are. And so I start to look through some of these. We get that guy up there, and we go, all right, so how high is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a max of 10. And then I look for my lowest point, and I have lots of choices, it looks like here. So it looks like my min, 1, 2, 3, -4. And so I'm going to use those two values to plug into both my amplitude and my midline equation. And we'll talk how we actually, again, might be able to get these without all these formulas. We'll see. So max minus, be careful, that min is a negative, and the minus is part of my formula, so it's minus negative. It's not just -4 in this case. Divide by 2. When we minus a negative, that becomes plus. So 10 plus 4 is 14. Divided by 2 is 7. Okay, my amplitude is 7. We'll be able to see that more in just a minute once we get our midline calculated. So a couple of things to mention on the midline. This we're actually going to draw into the graph. And the only difference formula-wise between the midline and the amplitude is that we're going to be adding the max and the min together to find that middle line. So I'm like, all right, so 10 plus -4 divided by 2. 10 plus -4 would be like 10 minus 4, which is 6. Divided by 2 is 3. And when we have a midline, the midline is actually the equation of a horizontal line. So to get that put into my picture, I go over and I'm like, okay, y equals 3. 1, 2, 3. And I'm going to dot a line across here. And this is where I want to show you where you may be able to do both of these without doing an algebra equation, where you might be able to just eyeball it. So when I'm trying to find my midline, which is what I'd find first, if I find my max and I find my min, and I just start slowly counting a line at a time until I get to the one in the middle, I'd be able to count that way and say, oh, it's 3, and do it that way. If I have my midline and I want to find my amplitude, I just say, hey, how far is it from 3 to 10? 7. How far is it from 3 to -4? 7. And I can do it that way. So the equation works, visually works, and then we've got the period. We talked a little bit before about when we were looking through these, we're trying to figure out where does the pattern start and then stop. So let's just say we started here. And we're like, okay, so I'm following along. Just kind of watch for right now. Normally what's going to occur is when I get back to the beginning, okay, you're like, well, how do you know that's the beginning? How do you know it kind of stops right here? Because if I'm following the pattern right, okay, if I start again here, my pen marks should do the exact, actually, let me do it with a color here. my pen marks should do the exact same thing. And if they do the exact same thing start to finish, that's another cycle, that's another period. So that's how I can kind of tell, until we get used to seeing what a sine function or a cosine function looks like. Then you'll know it that way. But for now then, my period would be, how far is it from where it starts to where it stops? And again, we're looking horizontally at x values. 1, 2, 3, 4. Or if I would have started here to here, 1, 2, 3, 4. It'll be the same every time. And I can find my period. Those are all three things that come into play when we're graphing a sine or a cosine function. Okay, so you've kind of been getting prepped for this over these past couple of days as we've been doing some of this equation solving. So as we move down now, and we're actually going to start to graph with some of these, I'm going to put you at ease on a few things. Okay, first, are you going to have to know that whole chart? Heck no. Okay? Because basically what we're going to do is we're going to simplify this down to 5 basic points. Okay? So my angle measure and my sine. We are going to have, should have another slot in here, but we don't have it, so we're going to put it in. 0, 0 will be one of the spots we're at. Pi over 2, 1. Pi 0. 3 pi over 2, negative 1. And 2 pi 0. Basically, I'm looking for all of the places on the table where it's just ones and zeros. Okay? The other stuff, sure, comes into play if we were getting into the unit circle and some of that other stuff, but for our graphing purposes, those 5 points are going to be the basis of everything that we do. And that's one of the things we're going to be putting on our card here in a little bit. So, like we kind of said above, but let's go over the vocab again. When we're doing these, my amplitude is the distance, which means it's always positive. Distances are positive, they're absolute values. From the midline to the highest peak or the lowest valley, to the min or to the max. And we just got done kind of talking about that up in the warm-up. If my midline happens to be the axis in this case, how far is it to get to the top? How far is it to get to the bottom? It needs to be the same. So like if I count sometime with an amplitude and it's like up 2 or down 3, something went wrong somewhere. But we'll chat about that as we do these. And then here's our new bit of information, okay? Period isn't new. Period's the amount of time it takes to complete a pattern. Here's what is new. 2 pi is what the sine function's period is, okay, for the normal or for the parent graph. And if you look at that little chart back up at the top again, you look at, starts at 0, it ends at 2 pi, which is 2 pi apart. So those things kind of go together as we're starting to do our graphing with this. Okay? So you're like, okay, amplitude and period back, okay. We still haven't done anything with this card, Harty. It's coming. It's coming. We're almost to the card. So as we flip over, there's one other thing that kind of comes into play with our amplitude and our period. So as we look at a sine function, it looks kind of weird. Y equals a sine bx. Whoa, too many letters. Okay, the amplitude again is going to be my a value. It's the absolute value though. It's always going to be positive. I'm going to keep writing this over and over to kind of stress this to you. Always positive, always positive, always positive. The period may not be 2 pi every single time, okay? If there's a number in front of x, if there's a number, sometimes we also see this other thing for an angle measure called theta. It looks like a circle with a line in the middle of it. Same thing. That number in front of it will divide 2 pi by, and that'll become my new period. we'll chat about that too here as we do the example on the bottom, and then I do one of the homework ones with you too to kind of let you see how this is going to work. So, what's the period of each sine function? So we're going to keep doing this 2 pi over b thing. So I look at the first one, y equals sine 8x. Okay, my b value is 8. So I do 2 pi over 8. Now I want to reduce that as far as I can. But if you go to put it in a calculator, the only part you're looking to reduce is the coefficient part. Don't touch pi. Don't use 3.14. 2/8, math enter if you need to, which would be 1/4 or pi over 4. So actually what that means is my graph's going to get kind of squished, but we'll get to that. What if b is a fraction? Here's where I've got to use a little common sense. 2 pi over b. Could I stick that in my calculator? I suppose I could, but I still want you to know why things occur. So let's kind of work this one out. So if I do 2 pi divided by 1/3, we're going to take a roll back down memory lane here. When you're dividing by a fraction, what do you do to the second fraction? We flip it over, and it becomes a multiply problem. So 1/3 becomes 3 over 1, and then we just multiply across. 6 pi over 1, or 6 pi. So when your b value is fractional, okay, when your b value is less than 1, let me put it that way, your period's going to get bigger. When your b value is above 1, it's going to get smaller. When we get down here, okay, what's the amplitude of each sine function? Again, the amplitude is the absolute value of my a. So here, my amplitude's 2. It's the number in front of my sine function. This is where you got to be careful, though, on b. We'll find out that -4 will change the way my graph looks, but as far as the amplitude goes, it's still positive. Amplitude is always positive. That should be one of the layup questions when we get to a summative here on what that's going to look like. And so as we do these, and I'm not going to do every single one here as we're rolling along. Thank you. So let's take a look at A and B here. So I look at this one. Find the amplitude. Okay, that should always be the easy part. Okay, now the period. The period is different than just finding b. Okay, my b value is 4, but my period is 2 pi over b, where I reduce that coefficient number if I can. 2/4 reduces to 1/2, or pi over 2. And if you put 1 pi over 2, that's fine. That's not going to get you in trouble. It's not wrong. And that's what I'm going to roll through these with as I'm doing my labeling. Okay, my A is 1/2. My amplitude is 1/2. So we're going to have a squished graph. My B value is 1/2. So if I remember back up to example B here, hey, that means when I'm dividing by 1/2, that's the same thing as multiplying by 2. And if you remember that, you don't want to write it out and then write it out again, that's fine. Multiply across. My period's 4 pi. Okay, it got bigger, which is what it's supposed to be anyway. So you're like, okay, Harty, we are to the last example in this note sheet. We still have not busted out the note card. Well, here it comes. So, when we're doing this, I'm going to have you do two things as we get prepared here. So on the front of your note card, And you can see mine's folded in half, and that's probably a good idea for you to do too. So fold it in half. We're going to put sine at the top of one. We're going to put cosine at the top of the other one. Now cosine we are not going to see for a couple of days here because we're just going to focus on sine right now. But what I'm going to do here is I'm going to share with you, or what we're going to basically do, is when we were back on the front here, those 5 values I boxed in, we're just going to take the values along the bottom here, okay? So I'm going to put 0, 1, 0, -1, and 0. And what I'm going to use this for is, when we start to do our graphs, okay, these are going to be the y values that I have for my base graph. Okay? Now, can those change if my amplitude changes? Yeah. Okay? What I'm going to have you do on the other side is write what we're going to call our parent points for radians. Okay? These are going to be the values that we put on the x-axis. These are going to be our angle measures. And again, these are my base ones. They can change with my period. And so what I'm going to do now is, with those ones we boxed in, I'm going to take what are called the radian angle measures from that, and I'm going to jot those down. So this way, when I go to graph, I've got something to reference when I'm making some of these adjustments. There might be a little side work involved, depends, but at least it's going to give us a good solid foundation to be starting with. I'm going to try and keep this held while I flip this. We'll see how this goes. Okay, so graph y equals 2 sine of 1/4 x. You're like, oh dear gracious, what am I supposed to do? Okay, we're always going to graph 5 points, and we're going to be starting at 0. So I'm going to put 4 somewhat equally spaced lines to the best of my ability right after it. Since we're doing a sine graph, when I go to graph, and I just put this down a little ways on the bottom, I like to make a little reference for what the normal parent points would be, just to get my head thinking about, okay, where does this go? How does this work? So I take a peek at this for a second, and I go, okay, what do I know? I know my amplitude is 2. Okay, so what does that mean? Normally, when we graph a sine graph, my points would go from 0 to 1 to 0 to -1 to 0. It's going to be kind of this curve, this nice kind of up and down and back up curve. It's going to kind of look like an S on its side with a sine graph. However, if there's a value in front, that's going to change that, but we always do that second. What I'm going to lock here in on is that my b value is 1/4. We always got to figure out our period first. Okay, so this is job 1. B value is 1/4, so my period is going to be 2 pi divided by 1/4. Which is the same as 2 pi times 4, or times 4 over 1, which would be 8 pi. So here's what that's going to mean to us. If my period is 8 pi, it's going to start at 0, and this last line is going to be 8 pi. Now here's how we're going to figure out the rest. And since we got room on this note sheet, I'm going to do it right on the note sheet instead of having the card do it. So we're just going to call this my radians here. And I'm just going to use those same 5 angle measures that we've got on the other side of your card. When we are figuring out a period, okay, we're always going to take whatever our b value is, and we're going to multiply by the inverse. We're going to multiply by the flip. So here, we're going to multiply all these values by 4, because we flip it. So we're going to multiply, and I'm going to do it by 4 over 1, because we have fractions on some of these. And I want you to see how this works. Now, when we get to a point that we're using the card, what I'm hoping you'll do is, you'll just kind of use this as your side, and now you can kind of do your side work like we are here next to it. That's going to be our goal. So you're like, okay, so why am I doing this? So we get the right points here. So here's my actual measures. 0 times 4, last I checked, is 0. So that's going to be my first point. If I multiply across here, I get 4 pi over 2. But 4 divided by 2 is 2. Okay, so I'm multiplying across here and simplifying. Whatever I get in the end is going to be my answer. Pi times 4 is 4 pi. Okay. 3 times 4 is 12. Divided by 2 is 6. And 2 times 4, even though I already know that one, is 8. So whenever you're doing your graph, okay, if there wasn't a value here, those are my measures that I use on my lines. But if there's a b value, we're just, again, going to take whatever that b value is, we're going to flip it, we're going to multiply. Those are new. So that's my first job. My second job now is I'm going to take my sine values that I put here, or I'm going to look at my card while I do it. And what am I going to do? I'm going to multiply them by the amplitude. 0 times 2 is still 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2 is 0. And we do our best to make a curve out of this. Okay, we don't want jagged lines. We're just kind of going to with it to see how that's going to go. So you're like, okay, I kind of see what he's doing. I got to do this period thing first to do these. And then I got to do this a value thing with these values to do this, okay? So again, these values, okay, sine and cosine have to do with my a value. We're going to multiply times the amplitude. When I get to my parent points, these have to do with b, okay? Have to do with the change in my period. So when we start to look at some of these, and we're actually working on them, I'm just going to grab myself a maybe. Ooh, almost made a mess. When I start to take a look at some of these, so let me pull up a couple of possibilities. So hey, you're even going to get some homework out of me. This is a good day. So let's see here. Where's one of my first ones we get to play? Sketch a cycle. 15. Ooh, that's a good one to start with. Okay. So homework help on the way. So we're on 856, number 15. And number 15 is, we're told the amplitude is 2 and the period is 2 pi over 3. Okay. So I remember from a second ago, okay, the period stuff, ooh, that's nice. They gave me the period. I don't even have to calculate it. That's very nice of them. So that's going to be my first job. So I know when I go to graph, 2, 3, 4. And I know 0 is always going to be my first one. So since the period's 2 pi over 3, that's my last line. 0 is the first one. I got to figure out the 3 in the middle. So you're like, okay, so, but you just told us we had to multiply by the flip of b. How do I know what b is? Remember, the formula for my period is 2 pi over b. If this is 2 pi over 3, I think it's going to be pretty easy to figure out what b is. But let's say it's not that easy sometime. What if it was something different? How would I figure it out? This. I'm going to do a little bit of algebra. I'm going to set my period equal to my formula. And I'm going to cross multiply. And since I want to know what b is, whatever's with b is what I'm going to divide both sides by. 6 divided by 2 is 3. So 6 divided by 2 is 3. So what am I going to do? I'm going to bust out my parent points here. And if I'm going to use my little card, because I don't want to write all this out every time, okay. So I kind of start looking, and I'm like, all right. What am I going to be multiplying by? I'm going to be multiplying by 1/3. I take that and I flip it. Flip b. 0 times 1/3 is still 0. Okay. If I want, I could even do this so I can physically look as I'm doing them. Pi times 1 is pi. 2 times 3 is 6. Pi times 1 is pi divided by 3. 3 pi times 1 is 3 pi. 2 times 3 is 6. But that reduces. Pi over 2. And 2 pi times 1 is 2 pi over 3. There, ladies and gentlemen, are my angle measures. The ones that go on the lines. Okay? That's probably for most of you the part that's going to cause the biggest challenge. But that's again why we've got this to start, and it's just multiply by 1 over b. And even if you wanted to do that, you could be like, okay, this is times 1 over b. If you really want that extra reminder more than just that it's b. Okay, now, how do I do the points? Well, let's see. I'm doing a sine graph. So I'm like, okay, the first one, 0 times whatever my amplitude is. 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2 is 0. And I curve it, and I work it that way. So there is some thought process to this. I'm not going to tell you there's none. But again, it's not going to be anything that's going to run us too terribly awful here. I'm trying to find the weird ones as I go here to see 122. Yeah, let's do that one. That's not a bad idea. All right, let's do that. We're going to do 21. 21's weird. Okay, 21. Y equals sine pi theta. Ooh. Okay. So here I look and I go, all right, what do I know? Hey, Harty, there is no number in front here. So what happens there? Means my A value is 1. So not much is going to happen with that. But there is a number in front of my angle measure. My B value is pi. Now that's kind of weird. Like, well, wait. So if my period is 2 pi over B, so So my period's 2? Yes. Okay, it doesn't have to have some sort of pi every single time. So I know it starts at 0. I know it ends at 2. So I go back and I think again, and I go, okay, so my b value was pi. Get my radians back out here. So what am I going to do? I'm going to multiply by the flip of that. I'm going to multiply by 1 over pi. And again, some of you may be able to just eyeball it. You may not have to literally write it out like I am here. And if that works for you, that's fine. But if you need to do this, especially at the start, do it. It's too much work. No, it's really not to get the concept. So here, 0 times anything is 0. Okay. Pi times 1 is pi. 2 times pi is 2 pi. Reduce the fraction. The pi's cancel. It's a half. Here, pi over pi. All the pi's cancel. It's 1. 3 pi times 1 is 3 pi. 2 times pi is 2 pi. I'm just multiplying straight across. 3 over 2. And 2 pi over pi, miraculously, is 2. Just like the period is. So I go, okay, so this is 0, 1/2, 1, 3/2, and 2. I've got my points. Since my a value is 1, my sign points aren't going to change at all. Multiply all these numbers by 1, I get them back. So, 0, 1, 0, -1, 0. Graph accomplished. So that's the type of thing that we're going to be looking at with these and kind of how we're going to be adjusting. So as we work through more of them, okay, because we're going to see this again the next time we're together, it's going to be, again, walking through with these, making sure that you're using your card, but you've got to keep practicing with them. That's the only way this gets better. Some of you, when you see difficulty, it's shut down. Nope, too stressed out. We got to find a way to fight through that, okay? So try them out, check answers, take a quick picture if you need of the book, and we'll get you set from there.